like a basic sound file, you know, so you've got your, this is my sound file. Right, it's not my signature. There's two terms. There's sample resolution and there is sample rate. Yeah, or sometimes it's called bit rate. Heard of that?
Yeah.
Okay, cool. So with the sample rate, that is the number of, it's the intervals, or the amount of times per second that you take a sample. Okay, so that's the sample rate or the bit rate. But with the sample resolution, it's how much information you record about the height or the amplitude of the wave. So if you had a sample resolution of 8 bits, for example, an 8-bit sample resolution, you would be able to record the height of that wave in 8 zeros and ones. But if that's all the ones, right? Something further on, like this one, this sort of amplitude, might actually be slightly different, but because we've only got 8 bits, it's still ones. So it makes the track sound a bit more fake, artificial. Okay. If you increase the sample resolution, then you've got 16 bits, and then you can determine that instead of being 8 ones and 8 ones, this first one might be 2 zeros and then 14 ones, and this one might be 1 0 and then 15 ones. And the slight difference in amplitude, being able to detect the difference in amplitude would mean that you've got a more realistic sounding audio track later on.
So the more bits, the more realistic it sounds.
Yeah, exactly. Yeah. But the sample rate is the amount of times per second that you take a reading from the analog input, and the higher the sample rate.
The sample rate is the same sample.
Well, no, sampling is everything, right?
Fine.
But if you talk about 16-bit sampling, that's your sample rate. Okay, so it's that part 2 question.
Okay, yeah.
So if you've got an 8-bit sample rate, you're taking, it's quite wide gaps between the samples. 16-bit is more compressed. 32 bits is even more, tighter gaps between each of the samples that you take, and then.
So the more bits you have, the tighter the sample rate.
Yeah. So mostly, sort of recording studios use 24-bit audio sampling.
Yeah.
Some might go for 32-bit audio sample rates, not because it sounds any better, because like photos, there's a limit to what the human eye can detect, and we can detect about 16.7 million colours, which is 24-bit. But it's the same with audio. We can only detect about 24 bits. But a lot of the times recording studios record at 32-bit, so that, and then sort of and then convert down to 24 bits for CDs or.
Would it help in any way?
I think it's just, it's always the same kind of idea. If you've got a better quality level of inputs, you can always return to it at a later date. And so if you're going to be compressing a 32-bit song, a 32-bit sample rate track into an MP3, it'll sound better than an 8-bit sample rate song being compressed into an MP3 of the same size.
Yeah.
So, sampling. If I just do my quick sketch. Okay, this is the microphone. Okay, analog signal is input from a guitar or from someone singing, and it's passed into a computer, and the computer uses something called an ADC, which is an analog to digital converter. Yeah, and then that turns converts it into a stream of zeros and ones.
Okay.
Okay, digital part.
Yeah.
But in between, what it does is sampling. Okay,
Oh,
so it uses sampling to do this. So the first step is it takes a record of the amplitude
Yeah.
at set intervals. And then that amplitude is turned into binary.
Oh, fine. Oh, it's not too bad then.
No, it's not too bad. So, if I was, I don't know, singing or talking into the microphone,
Yeah. It would
if I've got an 8-bit sample rate, it's doing it like once every second.
Yeah.
For example, if it was 16-bit sample rate, it's doing it once every half second,
Yeah.
and it records the amplitude, turns that into binary, but at the sample resolution. So if the sample resolution is 8 bits, it records 8 bits. If it's 16-bit sample resolution, it records 16 bits. And then it turns into binary, and then the binary is combined together at the output.